Assalamualaikum everyone. This is Mahmoudul Hassan, your course teacher for Electrical Circuits to AC Circuits. I know this setup isn't liked by everybody, but we have to manage with this, so please bear with us. Before we start chapter 10, I'd like to go through chapter 9 and revise all the things we've done till midterm. In chapter 9, the name of the chapter is Sinusoids and Phasors, and we've covered sinusoids, phasors, phasor relationship for circuit element, impedance and admittance, Kirchhoff's laws in frequency domain, impedance combinations, and applications as well. We've seen phase shifters, we've seen AC bridges. A sinusoid is a function that has the form of sine or cosine function. As you can see here, this is the red line is the sine function, and the blue dotted line is the cos function. We've seen why studying sinusoids is so much important. We've seen singularity functions. Singularity functions are the functions that have that are discontinuous at particular points, or the derivatives are singular at particular points. We've seen unit ramp, unit step, unit impulse function. We've seen periodic functions. We've seen examples of periodic function. Here you can see a voltage having the waveform of a sinusoid. We've covered all these things in midterm. We have shown you how to figure out phase difference using algebraic, using time domain representation, and also phasor representation as well. These trigonometric identities, as you can see in the slides, will help you find the phase difference. And we have done particular examples showing the phase difference. And phasors are complex numbers that represent the amplitude and the phase, and phasors make the calculations much more easier than if we try to do it in time domain. The calculation would be much harder and sometimes impossible to find out. Almost impossible, because the calculation gets bigger and bigger. But with phasors we can always have a simple approach and simple solution to the problems at our hand. We've seen phasor operations. We've done some phasor problems, and you should follow the class lectures for this topic, phasor relationship for circuit element. I had done that on the board, and if the circuit has resistive element, it does not provide a phase difference between the voltage and current. If there is inductor involved, the current lags behind the voltage by 90 degrees, as you can see here. And if the element is a capacitor, then voltage lags current by 90 degrees. Impedance is the direct opposition to current in AC circuit, and admittance is the reciprocal of impedance. Impedance combinations. Bacha Alamkir bhai asked me about how these equations came. There is a derivation in chapter 2 of your reference book in article 2.3. there is a derivation for Woodstone bridge, and the same derivation goes for these combinations, because impedance and resistance act in the same manner. this came in your midterm exam. I hope everybody can solve this problem now. Here we have a capacitor, and we can see capacitor makes one voltage lag behind. We've seen AC bridges as well. That's it for the revision of chapter 9. We'll start chapter 10 today. Thank you.